Hey, Doc Sig here to talk about solving for percent composition of chemical formulas. So what are they? Percent compositions are used to determine the percentage of an element in a compound. So we have the formula where we have the mass of 1 mole of the element, let's say oxygen, over the mass of 1 mole of compound, let's say H2O, times 100 because it's a percentage. There's a few steps I've included for you to follow, and then we'll go through some problems. Step 1. You got to calculate the molecular or formula weight of the compound. Step 2. Use the formula to calculate the percent composition of each element. So that's that formula I started out with. Step 3. This is just to check yourself. See that all your values add up to 100. If they don't, something went wrong. All right, let's start with C2H5OH. We got to get the molecular weight. So carbon, I have 2 of them. So 2 times 12.01, I get that 12.01 from the mass on the periodic table. And when I multiply those together, I get 24.02. Hydrogen, now watch out. I have an H5, but I also have the H on the OH on the end. So I have 6 total. So 6 times 1.01, again, the 1.01 comes from the periodic table, equals 6.06. Oxygen, I only have 1, so 1 times 16.00 is going to equal 16.00. I'm going to add them all up, and I will get 46.08 grams per mole. All right, that's done. And then I'm going to take apart each of those to get the percent composition. So let's start with carbon. Percent composition of carbon would be from my molecular weight, the 24.02 grams per mole, over the molecular weight, the total molecular weight, 46.08 grams per mole, times 100, and I get 52.13%. Percent hydrogen, I'm going to take the 6.06 grams per mole divided by the 46.06 grams per mole, times 100, I get 13.15%. Percent oxygen, I'm going to take the 16.00 grams per mole divided by 46.08 grams per mole, times 100, and I'm going to get 34.72%. I'm going to see that all of these add up to 100, and they do. Good. All right, let's try aluminum hydroxide. Again, we're going to start out by getting the formula weight. So aluminum, I only have 1. 1 times 26.98. Again, the 26.98 comes right from the periodic table, is equal to 26.98. Oxygen, I have 3 because the 3 distributes in. So 3 times 16.00, which is 48.00. Hydrogen, I have 3 because the 3 on the outside of the parentheses. 3 times 1.01 is equal to 3.03. Add them together, 78.01 grams per mole. All right, let's solve for this. We're going to have percent of aluminum, we'll start with. I'm going to put the 26.98 grams per mole over the total of 78.01 that I calculated previously, times 100, 34.59%. Percent oxygen is going to be 48.00 grams per mole divided by 78.01 times 100, 61.53%. Percent hydrogen, 3.03 divided by 78.01 times 100 is 3.88. Going to see that they all add to 100, and they do. One last one, and then we'll change it up. So I have NH4, parentheses 2, CO3, ammonium carbonate. Start out with my nitrogens. I have 2 nitrogens, so 2 times 1401, 28.02. Hydrogen, I have 8, because 2 times 4 is 8, times 1.01, so I get 8.08. Carbon, I have 1. 1 times 12.01, so I get 12.01. And oxygen, I have 3. 3 times 16 is 48. Add them all together, I get 96.11 grams per mole. Percent nitrogen is going to be 28.02 divided by 96.11 times 100. I get 29.19%. Percent hydrogen is 8.08 grams per mole divided by 96.11 grams per mole times 100, 8.41. Percent carbon, 12.01 divided by 96.11 times 100, I get 12.50%. Percent oxygen, 48.00 grams per mole divided by 96.11 grams per mole times 100, 49.94%. Let's see if they all add up to 100, and they do. Okay, so what happens if I'm missing a compound? All right, so this question is going to ask, what is the quantity of oxygen in a 20-gram compound of oxygen and zinc? So we know we have only two components. After decomposition, I'm left with 16.07 grams of zinc. Well, first and foremost, my initial compound at 20.00 grams, I'm going to subtract the 16.07 of zinc, and that's going to leave me with 3.93 grams of oxygen. Now I'm going to go into the formulas I've been doing. Percent zinc will be that 16.07 divided by 20, because that's already calculated and given to me in the question, times 100, I get 80.35%. Percent oxygen is going to be 3.93 grams per mole divided by the 20.00 times 100, I get 19.65%. See if they have to 100, and they do. There you go. Percent composition, how to calculate. See you next one.